Welcome to math class. I'm Julia Alalibo, and today we'll be studying the theme algebraic operations. And our topic for today is simple equations involving fractions. Now, by the end of the lesson, you should be able to clear fractions in algebraic equations, solve simple equations involving fractions, and also solve simple word problems on simple equations involving fractions. Now, the first thing we are going to be talking about is clearing fractions, how to clear fractions. This is usually the first step in solving any equation. If there are any fractions, it must be cleared. When you're asked to solve an equation and there's a fraction involved, that fraction must first be cleared before the equation can be solved. To clear fractions, multiply each term in the equation by the LCM of the denominators of the fraction. So if you want to clear a fraction, the first thing to do is to find the LCM of all the denominators in that equation and then multiply each term in the equation by the LCM. So let's look at an example to understand what we are saying. Now, the first example, solve for x in the following equation. X over 2 plus 4x plus 5 over 3 is equal to 9. Now, the first step, as I said, is to find the LCM of the denominators. The denominators are 2 and 3. The LCM of 2 and 3 is 6, because 2 here, 1. This is 3. 3 here, 1, 1. 2 times 3, 2 here times 3 here is equal to 6. So this is the LCM of 2 and 3, 6. The second step is to multiply both sides of the equation. This equation we have here has two sides, the left-hand side and the right-hand side. Multiply both sides of the equation by the LCM. And both sides of the equation we multiply every term. So this is one term, this is another term, and 9 is another term on its own. So we multiply each term in the equation by the LCM, 6. So this is what we have here, 6 times x over 2, which is the first term, plus 6 times 4x plus 5 over 3 is equal to 6 times 9. So we can simplify this. 6 times x over 2. 6 divided by 2 gives 3. So 3 times x gives us 3x. Now 6 times 4x plus 5. 3 divided by 6 gives us 2. So we are left with 2 times 4x plus 5. And 6 times 9 is 54. Now expanding this bracket, we'll have 3x plus 2 times 4x gives 8x. And 2 times 5 gives 10, equal to 54. 3x plus 8x is 11x, plus 10 is equal to 54. Taking like terms, 11x will be equal to 54 minus 10. So 11x is equal to 44. Then x is equal to 44 all over 11, and this is equal to 4. So we can substitute the value of x, which is 4, into our equation to check if our answer 4 is correct. So the value of x is 4. So 4 all over 2 plus 4x. X is 4 plus 5 all over 3. This should give us 9. If we do not get 9, then we know that our answer, x is equal to 4, is not correct. So 4 over 2, this gives 2, plus 4 times 4 is 16. 16 plus 5 is 21. So we have here 21 all over 3. This is equals to 2 plus 21 all over 3 is 7. 2 plus 7 is 9, which is what we have here. So x is actually equal to 4. Example 2, solve for x in the following equation. 2 times 4x minus 1 all over 3 is equal to 9 times x plus 1 all over 4. So to solve this, the first step is to find the LCM of the denominators. The denominators are 3 and 4, and the LCM of 3 and 4 is 12. The next step is to simply multiply the LCM by each term on the right-hand side and the left-hand side of the equation. So we have 12 times 2 times 4x minus 1 all over 3 is equal to 12 times 9 times x plus 1 all over 4. After multiplying, we are left with 4 because 12 divided by 3 gives us 4. And then we have 2 times 4x minus 1 is equal to 12 divided by 4 gives us 3. So we are left with 3 times 9 times x plus 1. Now expanding our brackets, 4 times 2 here gives us 8. So we have 8 times 4x minus 1. And 3 times 9 here gives us 27. So we are left with 27 times x plus 1. Now expanding the bracket, 8 times 4x, 32x. 8 times minus 1, minus 8. 27 times x, 27x. And 27 times 1 is 27. Now bringing like terms together, 32x taking 27 across the equal to sign becomes 32x minus 27x. Then this becomes 27 plus 8. 32 minus 27 gives 5x, and 27 plus 8 gives 35. Therefore, x is equal to 35 divided by 5, which is equal to 7. So x is equal to 7. You can also put the value of x into the equation to see if we are correct or not. So let's do that. We have 2x is equal to 7 minus 1 all over 3. It should also be equal to 9, 7 plus 1 all over 4. So 4 times 7 here is 28. 28 minus 1 gives 27, and 27 times 2 gives 54. So we have 54 all over 3. 7 times 1 here gives 8. 8 times 9 gives 72 over 4. 54 divided by 3 gives 18. Also, 72 divided by 4 gives 18. 18 is equal to 18. And from our question, we're told that the left-hand side is supposed to be equal to the right-hand side. So if this is right, x is equal to 7 is the correct answer. Now, unknown denominators. For the previous example, we worked with situations where the unknowns were the numerators and what the denominators were numbers. There were no unknowns as the denominators. So we'll be looking at unknown denominators. That is where the denominator is unknown. So example 1, find p in the equation below. 1 over p plus 2 is equal to 5 over 2. We apply the same method we used before. We find the LCM of the two denominators. Find the LCM of p and 2. LCM of 2 and p is 2p. So we multiply the LCM by each term in the equation, the left-hand side and the right-hand side. So we have 2p times 1 over p plus 2p times 2 is equal to 2p times 5 over 2. 2p times 1 over p leaves us with p because p cancels p here. So we are left with 2. 2p times 2 gives us 4p. And 2p times 5 over 2 gives us 5p. Now bringing like terms together, 4p minus 5p will be equal to minus 2p. And 4p minus 5p equal to minus p. Minus p is equal to minus 2. If minus p is equal to minus 2, p is equal to 2. So the same method applies when the unknown is in the denominator rather than the numerator. Now another example with an unknown as the denominator. Find y in the equation below. 2 over y minus 3 all over 8y is equal to 1 over 4. The solution, we find the LCM of y, 8y, and 4y. To find the LCM, we use the normal method of finding LCM, 8y and 4. So we start with 2. 2 cannot divide y. So 2 divide 8y, we are left with 4y. And 4 divided by 2, we are left with 2 here. 2 goes in again, y, 2y, 1. 2 goes in again, y, we are left with y here and 1. And y goes in here, we are left with 1, 1, 1. So the LCM is 2 times 2 times 2 times y, which is equal to 8y, which is what we have here as the LCM of 8y and 4. So we multiply each term by the LCM. 8y times 2 over y gives us 16 because y cancels out y. So 8 times 2 gives us 16. 8y times 3 over 8y. 8y cancels 8y. So we are left with minus 3. And 8y times 1 over 4 gives 2y. 16 minus 3 is equal to 13, which is equal to 2y. And then y is equal to 13 all over 2, which is equal to 6 whole number 1 over 2. So what problems? Now sometimes the question given to us might not be in an algebraic form. It may not be an equation. It may be a word problem. So we would need to convert it from a word problem to an equation. So moving on to word problems in simple equations involving fractions. So sometimes the problem or the question given to us may not be an equation, an algebraic equation. They may be word problems, and we'll need to convert them from word problems to algebraic equations in order to solve them. So there are some steps we must follow when solving word problems. The first step or the first thing to do is to designate a letter to the unknown, because the question will always carry an unknown that you are asked to find for. So you designate a letter to that unknown. Number 2, you convert the statement to an algebraic equation. And lastly, solve the equation to get the values of the unknown. So our first word problem. A man sells a number of pencils for 440 naira in total. If the average selling price of one pencil is 8 naira, how many pencils did he sell? The first step, as we said, in solving word problems is to designate the letter to the unknown. So the number of pencils sold is the unknown. So we say let that be x. Now from the second statement, it says if the average selling price of one pencil is 8 naira, average selling price of one pencil will be the total sales over the number of pencils. When we are told that the average is 8 naira, it means that one pencil costs 8 naira. The total all over the number of pencils is equal to 8 naira. And the total cost here is 440 over the number of pencils. We do not know that, and we said let that be x is equal to 8. So 440 all over x is equal to 8. Now this is an equation we can solve. We have converted the word problem to an algebraic equation, and we can solve this easily. So we multiply both sides of the equation by the LCM of the denominator. And since there's only one denominator, x, the LCM of x is x. So multiplying the left-hand side of the equation by x, we have x times 440 over x is equal to x times 8. So once we multiply this, x cancels out x, we are left with 440 is equal to x times 8 is 8x. So x is equal to 440 over 8. 440 divided by 8 gives us 55. That means the number of pencils the man sold is 55. He sold 55 pencils. Now, second word problem. Kelly has P pairs of total mass 16 kg, while Stanley has 3 P pairs of total mass of 27 kg. A. What is the average mass of one of Kelly's pairs? B. What is the average mass of one of Stanley's pairs in terms of P? And C. If the average mass of Kelly's pairs is 0.1 kg less than the average mass of Stanley's pairs, find the number of pairs they both have. Now we are told that Kelly has P pairs, and the total mass, the total is 16 for Kelly. And for Stanley, Stanley's total is 27 kg. But the number of pairs Kelly has is P. Number of pairs, call it P. While that of Stanley is 3P. Now the first question is, what is the average mass of one of Kelly's pairs? Average mass of Kelly's pairs is total mass of pairs all over number of pairs. So the average of Kelly's pairs is simply 16 over p kg. Now for Stanley, the average mass of Stanley's pairs is the total mass over the number of pairs. That is 27 all over 3p, which is equal to 9 all over p kilogram. Now the third question says, if the average mass of Kelly's pairs is 0.1 kg less than the average mass of Stanley's pairs. So Kelly's average pairs is equal to 0.1 kg less than Stanley's average pairs. 0.1 kg less means Stanley's average pairs minus 0.1. So this is what question C is saying in the mathematical form. Kelly's average pairs is equal to Stanley's average pairs minus 0.1, which is what we have here. Kelly's average is equal to Stanley's average minus 0.1. And remember, from question A, we've solved that Kelly's average is equal to 16 over p. So we have 16 over p for Kelly's average is equal to Stanley's average being 9 over p or 27 over 3p minus 0.1. So this is what we have here. So this is now our new equation. We formed an equation from the word problem, which is always the second step. We've converted the word problem to an algebraic equation. So now we can simply solve. And the next step is to find the LCM of p and 3p. And the LCM of p and 3p is 3p. How did I get that? Do p, 3p. To find the LCM, first 3, bring down p, and p is left here. P, 1, 1. So the LCM is 3 times p, which is equal to 3p. So we multiply each term on the left-hand side and the right-hand side by 3p. So we have 3p times 16 over p is equal to 3p times 9 over p, because 27 over 3p here is the same thing as 9 all over p. So times 9 over p minus 3p times 0.1. Now 3p times 16 all over p gives p cancels out p. We are left with 48. 3p times 9 all over p, p also cancels out p. 3 times 9 here gives us 27. Minus 3p times 0.1p gives us minus 0.3p. Now bringing like terms together, 48 minus 27 is equal to minus 0.3p. 48 minus 27 is minus 21. This is equal to minus 0.3p. And p is equal to minus 21 over minus 0.3. And once we do this division, we are left with 70. Minus 21 divided by minus 0.3 gives 70. So p is 70. And remember, from the question, we are told that Kelly has p pairs, while Stanley has 3p pairs. So if Kelly has p pairs, that means Kelly has 70 pairs, while Stanley has 3p pairs. That is 3 times 70 pairs, which is equal to 210 pairs, which is what we have here. So Kelly has 70 pairs, while Stanley has 210 pairs. Now, denominators involving binomials. It's also possible for an algebraic equation to be such that rather than having a single letter like we have done before, maybe 3 over p plus 7 over 2 is equal to 1 over p, find p. It's also possible that it can be in a binomial form like this. So we are going to learn how to find solution for this kind of fraction. So the same method applies. Find the LCM and multiply each term on the left-hand side and on the right-hand side by the LCM. Note that there's only one denominator, so we directly multiply both sides of the equation by the denominator. So x plus 2 times 7 all over x plus 2 is equal to 6 times x plus 2. So x plus 2 cancels out x plus 2 and we are left with 7. We expand the brackets here. 6 times x gives 6x. 6 times 2 gives 12. Now bringing like terms together, 7 minus 12 will be equal to 6. 7 minus 12 is equal to minus 5. So minus 5 is equal to 6, and x will be equal to minus 5 all over 6. So this is the answer to the value of x. The value of x is minus 5 all over 6. Example 2 on denominators involving binomials. Solve for a in 3 all over a minus 8 plus 2 all over 5 equals to 0. Now notice that the denominators are a minus 8 and 5. In this kind of situation, the LCM is simply 5 times a minus 8. So the denominators are a minus 8 and 5, and the LCM is simply the multiplication of the denominator, because a minus 8 and 5, their LCM is 5 times a minus 8. So we multiply every term by the LCM. The LCM is 5 times a minus 8. So we have 5 times a minus 8 times 3 over a minus 8. This is our first term. And then we have 5, this is our LCM, 5 times a minus 8 times 2 over 5. This is our second term. And then 5 times a minus 8 times 0. That's our last term. Now a minus 8 cancels a minus 8. So we are left with 5 times 3, which is what we have here. And 5 times a minus 8 times 2 over 5. 5 cancels out 5. So we are left with 2 times a minus 8, which is what we have here. And 5 times a minus 8 times 0 gives us 0. 5 times 3 here gives 15. Expanding this bracket, we have 2 times a gives 2a, and 2 times minus 8 gives minus 16, which is equal to 0. 15 minus 16 is minus 1, plus 2a is equal to 0. Now, bringing like terms together, 2a will be equal to, taking minus 1 over the equal to sign, 2a will be equal to 1, and a will be equal to half, or 0.5. So the value of a in the given question is 0.5. Now 4 is divided by the sum of a and 1. If the result is the quotient of 3 and a, find a. Quotient here means divided or division. So we are told from the question 4 is divided by the sum of a and 1. 4 divided by a plus 1. I told that it's equal if the result is the quotient, that is the division of 3 and a. Find a. So our LCM is a times a plus 1. Our LCM is the multiplication of the denominators. So a times a plus 1. So the second step is to multiply each term by the LCM. So we have 4 over a plus 1 times a plus 1 is equal to 3 over a times a plus 1. So a plus 1 cancels out a plus 1. We are left with 4a, which is what we have here. A here cancels out a. We are left with 3 times a plus 1, which is what we have here. So 4a is equal to, opening up this bracket, we have 3 times a gives 3a. 3 times 1 gives 3. Taking like terms, 4a minus 3a will be equal to 3. 4a minus 3a is a, and a is equal to 3. That means the solution to the question is a is equal to 3. So solving equations involving binomials as denominators are not really hard. They just follow the same sequence as solving equations without binomials. Another word problem which will lead to an equation involving fractions. A boy is 3 years older than his sister. 5 years ago, the ratio of their ages was 4 to 3. Find their present ages. Now, when dealing with word problems, we are told that the first step is to designate a letter to the unknown. So, let the sister's age, we are told that a boy is 3 years older than his sister. So, let the sister's age be S. If the boy is 3 years older than her, that means the boy's age is S plus 3. So, the boy's current age is S plus 3. So 5 years ago, from the second statement, the ratio of their ages was 4 is to 3. So the sister's age 5 years ago will be S minus 5. That's our current age minus 5 years ago. And the brother's age will be his current age being S plus 3 minus 5. If we solve this, say S plus 3 minus 5, this will be equal to S minus 2. And from the second statement still, we are told that 5 years ago, the ratio of their ages was 4:3. So 4:3. So now, we are going to convert this to an algebraic equation so that we can solve it. The ratio of their ages, this is the ratio of the brother's age, this is the brother's age to the sister's age. So if 5 years ago, their ratio was 4:3, 5 years ago, the brother was S minus 2 years old, which is equal to 4. Now the ratio S minus 2 over the sister's age 5 years ago, S minus 5, will be equal to 4/3, 3 being the ratio of the sister's age. So this is what it looks like. This is now an algebraic equation that we can solve easily. So now the LCM of x minus 5 and 3 is simply 3 times s minus 5. So we multiply each term by the LCM of the both denominators. So s minus 2 times s minus 5 times the LCM, 3 times s minus 5, will be equal to 4/3 times the LCM, 3 times s minus 5. So s minus 5 here cancels out s minus 5. We are left with 3 times s minus 2, which is what is here. And 3 here cancels out 3. So we are left with 4 times s minus 5. Now expanding our brackets, 3 times s gives 3s. 3 times minus 2 gives minus 6. 4 times s gives 4s. And 4 times minus 5 gives minus 20. Now, bringing like terms together, we have 3s taking 4s across the equal to sign. We have 3s minus 4s is equal to minus 20. Taking minus 6 across the equal to sign becomes minus 20 plus 6. 3s minus 4s is minus s. And minus 20 plus 6 is minus 14. Therefore, s is equal to 14. Therefore, the sister's age, remember from our solution, we designated the letter s to the sister's current age or our present age. So our solution has resulted in s is equal to 14, meaning that the sister's current age is 14 years. She is 14 years old, while the brother's age is s plus 3, that is 14 plus 3, which is equal to 17. So the brother is 17 years old, while his sister is 14 years old currently. The question says find their present ages. So presently, she is 14 while the brother is 17. Now this concludes our lesson for today. So a quick review of all we've done. So in solving equations involving fractions, we always clear the fractions first, and we do this by multiplying every term in the equation by the LCM of the denominators. After clearing the fractions, we clear the brackets, collect like terms, and solve. When solving word problems, the first step is to designate a letter to the unknown, convert the statement to an algebraic equation, and then solve the equation to get the values of the unknown. Now, a few test questions to see how well we've understood the lesson. So solve for x in the equation 2x minus 3 divided by 9 plus x plus 1 divided by 2 is equal to x minus 4. Option A, 29. Option B, 15. Option C, 19. And option D, 31. Now, to solve this, the first step, as we've learned, is to look for the LCM of the denominators. And the LCM of 9 and 2 is 18. So the LCM is 18. And then the next step is to multiply each term on the left-hand side and the right-hand side by the LCM. So we have 18 times 2x minus 3 over 9 plus 18 times x plus 1 over 2 equal to 18 times x minus 4. So we multiply this. 18 divided by 2 leaves us with 9, so we are left with 2, bracket open, 2x minus 3 plus, same applies here, 18 divided by 2 leaves us with 9, so x plus 1 is equal to 18 bracket open, x minus 4. Now expanding our bracket, 2 times 2x results in 4x. 2 times minus 3 results in minus 6, plus 9 times x results in 9x. 9 times 1 results in 9. 18 times x gives 8x. And 18 times minus 4 gives minus 72. Now bringing like terms together, we have 4x plus 9x minus 18x because it's crossing the equal to sign. And then minus 72 plus 6 minus 9. So 4x plus 9x minus 18x gives minus 5x. Minus 72 plus 6 minus 9 results in minus 75. Therefore, x will be equal to minus 75 all over minus 5. And this is equal to 15. So the correct option is option B. So if you chose option B, you are quite correct. Now to our last test question. A man is 21 years older than his son. The ratio of the man's age to that of his son is 5:2. Find their ages. So when giving word problems, the first step is to designate a letter to the unknown. So let the son's age, let the son be x years old. If the man is 21 years older than his son, that means the man is x plus 21. Now the ratio of the man's age to that of his son is 5:2. The ratio is also the same as the quotient. So x plus 21 over x is equal to 5/2. Now we have converted our word problem to an algebraic equation, and we can simply solve for x. The first step is to find the LCM, and the LCM of x and 2 is 2x. So we multiply each term by 2x. So 2x times x plus 21 over x is equal to 2x times 5/2. Now x cancels out x here, so we are left with 2 times x plus 21 is equal to 2 cancels out 2 here, so we are left with 5x. Now opening up the brackets, expanding the brackets, 2 times x results in 2x. 2 times 21 results in 42, which is equal to 5x. Now bringing like terms together, we have 2x minus 5x is equal to minus 42 because 42 is crossing the equal to sign. So 2x minus 5x, this results in minus 3x is equal to minus 42. So x is equal to minus 42 over minus 3, meaning that x is equal to 14. And we said x is the son's age. So the man's age is x plus 21. So his age is x here, 14, plus 21 is equal to 35. That means the question says find their ages. So the correct option is option B, 35 and 14. The man is 35 years old, while his son is 14 years old. I hope you understood the lesson on simple equations involving fractions. Do have yourself a nice time. Thank you.